Hi everyone, and welcome to another lesson about chemistry. Today we're going to talk about, well, several things, but probably the big thing is endothermic versus exothermic reactions. All right, so let's get started with, let's get started with what we would normally be doing here. All right, talking about it. There's a quick question they give you right here, right? What must a balanced chemical equation contain? Remember, we were talking about this last week. Remember, for it, every one element that's on the first side, right, on this side of the chemical equation going on here, like let's say titanium, if there's just one titanium, no other titanium over here, right, that means on the other side, you've got to have at least one titanium, right? And same thing, there's one aluminum over here, and there's one aluminum over there, so that would mean that this is a balanced chemical equation. It's a true statement. Right, so remember, you've got your products and your reactants going on here. You've got the yield sign, plus sign over here. Incidentally, that would mean, right? Can you tell what type of chemical reaction this is? That's one thing you're going to need to know for the test coming up at the end of the unit, or the assessment coming up at the end of this chapter right here. For this one, you've got a couple little pieces, right, that are broken up and they become one big thing. So this would be a type of synthesis reaction that's going on here. Right there. Oh yeah, same thing. Answer for it. Okay, so we want to talk about two different types of chemical reactions, right? There are what I like to call the movie chemical reactions and the non-movie chemical reactions, right? There are, or you could say it this way, there are the exciting chemical reactions and the boring chemical reactions, right? So that's kind of the thing we want to get to today. Is it going to be exciting, like movies? Think about movies, all the big movies that you can think of, right? Well, all these big movies that are going on here, they all have something in common with each other. What do all of these movies have in common with each other? I don't know, but we'll find out in just a really quick thing here. Oh, there's Boba Fett. Okay, let's start with the movie ones, the exciting ones. These are the things that are called exothermic reactions, right? When you're trying to figure out the difference between this one and the other one, we'll get to in a second here. Think there's an X at the beginning of exothermic. There's kind of like this X right here towards the very beginning. I always think of it like it's exciting, right? Think, in all those movies, wait, where'd they go? In all these kind of movies, they have exothermic reactions. Exothermic reactions are the kind of reactions you're going to pay your hard-earned money to go see in a movie theater or in today's world of streaming. They're the exciting chemical reactions, right? When you go to a movie and you're thinking, okay, it's a good action movie, believe it or not, chemistry is highly involved in that. You're thinking, I want to see some action, right? And action means explosions, right? If you've got a movie and something's on fire, something's exploding, something's zooming past something else, it's probably due to a chemical reaction. And those chemical reactions that do that kind of thing are called exothermic reactions, right? An exothermic reaction is a chemical reaction going on. But when the chemical reaction is actually happening, it's generating so much energy, it's giving off heat, right? That's exothermic. They're reactions that are really, really hot. Sorry, they're generating their own heat because of this, right? So exothermic reactions, think like, things that are on fire and creating smoke and stuff like that, right? Those are all exothermic reactions that are going on. Oh my goodness, okay. Now there are other chemical reactions out there, and these are known as endothermic reactions. And for many a moon, I've been picking on endothermic reactions because, well, generally they're boring. They're not ones you're going to pay money to go to a movie theater and see. I mean, endothermic reactions, trying to find some exciting ones. These are the exciting ones, mind you, right? Toast, right? That's endothermic. It's absorbing, even though it's absorbing heat, right? That's when the bread's being cooked and things like that. In fact, a lot of things being cooked are endothermic, right? Remember, in your kitchen, you've got a chemical reaction chamber called an oven. All that an oven is, it's a chemical reaction chamber to facilitate endothermic reactions, right? So you put things in, it adds heat to it, and that's where the chemical reaction goes for cooking food. So most food cooking is endothermic, right? Or even think like top of the stove, right? An egg, right? You crack open an egg from its shell, you put it in the pan. The egg is all kind of clear around the outside, and the yellow stuff on the inside, it's all gooey and slimy and everything like that. Whether you like to eat it like that or not is your own business, because that's kind of gross and it icks me out and everything, right? But when you cook it, right, that's endothermic. The egg is actually absorbing some of the heat from the fry pan that's getting it from the stove and everything like that. That's an endothermic chemical reaction. And I mean, think that clear stuff that was down here, right? Now it turns white and rubbery, also kind of gross, right? And then the yolk, if you cook it long enough, right, it turns solid too. Both of them, they're chemical reactions for it. Even photosynthesis, right? It's a chemical reaction too, and it's endothermic. So you can see these aren't really like the most exciting things, that are going on for it. Even melting ice cubes, I mean, it's not a chemical reaction going on there, but the process is endothermic, right? It's absorbing, the ice cube is absorbing heat from around it for it, right? So, yeah, you can see that they're not very exciting and everything like that, right? Oh, yeah, and yeah, here we have the moonfish, which is also known for, being endothermic. Now, there is one example, though, of an endothermic reaction in a movie that was like full screen. It was like the main thing. And to prove me wrong, right, everyone in the movie theater, when I was around it, was like, oh, they actually were like, whoa, that's cool. And it's endothermic. You don't recognize this? All right, let me play it quick. Let me play it really quick. Oh, yes. And of all movies, Star Wars, for goodness sake, there was an endothermic chemical reaction, and people thought it was really cool. Of course, in my personal defense, it is a movie special effect. It wasn't a real chemical reaction. It was actually a guy with a balloon. But anyway, that's side product, right? So, okay, some endothermic reactions might be kind of cool too. All right, so that's kind of the thing going on there. Let me show you. There's a short little video here about endothermic and exothermic video or chemical reactions.
It's the 4th of July in Ojai, California. A day for parades, parties, and fun. But the nighttime is really special because it's when everyone can watch fireworks. It's a fantastic show, but getting ready for it takes time. Almost 1,000 highly explosive fireworks are needed for this dazzling light show. It takes more than just explosives to make this show work. Behind all of the flash is a dedicated team of Ojai's finest pyrotechnicians, the firemakers. Today, most fireworks displays are launched with the help of computers. However, this show is done all by hand. The heat of a flame moving down a fuse gives fireworks the activation energy needed to begin a chemical reaction. When the burning fuse reaches the chemicals inside the firework shell, the chemicals undergo a rapid exothermic reaction, and the shell explodes into the air. What provides the activation energy that causes a fireworks shell to explode? As you watch this segment, think about the chemical reactions that take place inside fireworks. The Rotzi family has a special relationship with fireworks. They run Rotzi's famous fireworks in Cleveland, Ohio. While some companies say their business is booming, this is no exaggeration for the Rotzis. For over 100 years, this fireworks dynasty has been setting the skies on fire with displays that can still take your breath away. What makes these fireworks so exciting? The answer is the basic ingredient of all fireworks: an explosive mixture of chemicals made into a pellet called a star. Stars are made by highly trained and experienced workers. Making stars can be a dangerous task, and people without special training could risk an explosion and serious injury. The stars in fireworks are not shaped like regular stars. They can be shaped like spheres or cylinders. Stars are what provide the sound, light, and color that we see when a shell explodes in the air. The chemicals in the star include an oxidizing agent, a chemical that provides oxygen, a fuel, a chemical that burns, and other chemicals that provide color. The main fuel in most stars is a powdered form of the metal aluminum. Some examples of other chemicals that are added include strontium, which makes a red-colored flame. The addition of barium will make a green-colored flame, and adding copper creates a blue flame. It is important that the fuel in each star ignites without causing the star to crumble. To make sure that stars do not crumble, fireworks makers coat them with flammable chemicals that keep the stars together and make sure they will easily catch fire when ignited. When a single star is ignited, it burns for a specific amount of time and gives off heat and a certain color light. In other words, the chemicals undergo an intense exothermic reaction. Hundreds of stars are packed together in what is called a star bundle. Sometimes all the stars in one bundle are identical, resulting in a burst that is all the same color. Other times, different types of stars are packed in the bundle, resulting in a multicolored burst. There are many different types of aerial shells. Most have 4 parts. The first part is a packet of black powder taped to the bottom of the aerial shell. This is called the lift charge. The lift charge provides the energy needed to propel the aerial shell into the air. The second part is what is called the bursting charge. The bursting charge is inside the shell closest to the star bundles. The function of the bursting charge is to burst the shell open, ignite the stars, and push the stars outward in a pattern. The third part is the star bundle. Some aerial shells have more than one star bundle. Finally, the part of the aerial shell that provides the activation energy is the fuse. The main fuse first ignites the lift charge. It continues to burn as the shell lifts into the air, where the fuse ignites the bursting charge. In order to launch aerial shells, engineers load them into cylinders called mortar tubes. When the fuse ignites the lift charge, the black powder burns in an exothermic chemical reaction. The main product of this reaction is a rapidly expanding gas. The gas builds up pressure. Because it is confined by the tube, the only way the expanding gas can escape is out the top. The gas rushes upward, pushing the aerial shell out. As the gas is forced out, the aerial shell is propelled at a speed of about 1,200 meters per second. Some fireworks can reach a height of almost 400 meters. Once the shell reaches its maximum height, the fuse ignites the bursting charge. The shell bursts open, and the rapidly burning stars are spread out by the force of the bursting charge explosion, producing an awesome aerial display.
Very nice, right? So there you go. That's exothermic reactions. Hey, really quick, then the last thing that we're going to get to is this guy right here, the precipitate, right? All that a precipitate is another form of a chemical reaction. Well, when a chemical reaction is occurring, what happens is a solid is formed. Kind of like this guy right here, 2 liquids, right? There were 2 clear liquids, but this kind of cloudy stuff is really, it's just millions and millions of tiny, tiny little particles going on for it. So it makes kind of this nice, cool yellow kind of cloud that's happening for it. Right, so that's a precipitate, right, where you have a solid forming inside of the chemical reactions, or the chemical reaction, right? So, think about like, an egg. It was liquid, but then it becomes solid. Could be another example for that. Okay, we're going to end with this one, the joke of the day. If you're not part of the solution, you're part of the precipitate. All right, thanks for joining me. Remember to take the quiz.